Okay, for video 2 here, we've got problems 3 and 4 in 2-1. The only difference between questions 3 and 4 and the first two is that we have to make our triangle. We have to create and draw out the triangle first. So let's do that. So we've got this. I'll draw triangle. And because we're drawing the triangle, we get to pick which angle is our theta. So I'm just going to make that theta. Beautiful theta. Okay, but by doing that, now we've set which side is going to be which. Such as, this would be our opposite, adjacent, and hypotenuse. Again, we set that by picking that side to be that corner to be the angle we're working with. Now, all we're being given is secant is 9/2. Well, secant goes with cosine. Remember, those are inverses of each other. So if secant is similar to cosine, what we know, like right here, I'm just going to right off the bat say, hey, cosine is the inverse. That's 2/9. So I can answer that one right away. They don't even have a space. Notice there's only 5 listed here. It's because the 6th one has already been presented. So, but what I'm going to do is I'm going to use this cosine ratio to help solve my triangle here. So, so if I know that cosine is adjacent over hypotenuse, then that means that this side is 2 and that this side is 9. So the last thing I have to do is just take a minute and, I don't know, let's do orange. So we need to find the opposite side length. So we have 2 squared plus opposite squared, not 0. That's a really poor. It's no wonder they don't use O for variables very often. It looks like a 0. I'm sorry. That equals 9 squared. So that O squared, God, that is going to bug the heck out of me. O squared is equal to the square root of 9 squared minus 2 squared. I'm not even going to put it. I'm just going to say equals the square root of 77, because 81 minus 4 is 77. So, but again, that side length, let me get this back to red. I'm going to just simply leave that as square root 77. I do not want a decimal approximation for square roots. So with that said, let's fill out everything else we need to know. So sine is square root 77. Oh, no, not 2. That's a tangent. Erase. Be gone. There we go. Over 9. Cosine we already figured out. Tangent would be that opposite. So square root 77 over adjacent, just 2. Cosecant is going to go with our sine. Sine is going to be the inverse of sine. So cosecant is 9 over square root 77. We do not need to do anything with that. We can leave a square root in the bottom. For any of you old-time math people like myself, I actually would have had to what we call rationalize the denominator. We used to say we don't want square roots of any kind in the denominator of any fractions. Now, and I can get into it later if you really want, but now we can just leave those. So cotangent, we're going to flip tangent around and say 2 square root 77. So we have answered the question at hand. Again, these trig problems, you always make sure you reread the question and have answered everything that they're asking for. It just says to find the exact values of the 5 remaining trig functions, and that is exactly what we did. So let's move on to number 4. Number 4, we're going to have another triangle. Better keep to my color code. You do always want to make sure that you identify those right corners, the 90-degree corners, if possible. So I always label that. And just, again, to keep with things, I should have kept this blue for a second. I'm going to identify that same corner as theta. So working forward on that, what do we know? We know cosecant. So again, cosecant is the inverse of sine. So now we have the 6. Well, but it's a whole number. So what do? Well, we can look at any whole number at all, as a fraction where the whole number is just over 1. So now we have a ratio. Cosecant is 6 over 1, which means that sine is the opposite of that is 1 over 6. We're also going to say, well, now that we have sine is 1 over 6, sine is opposite, so that's 1 over the hypotenuse 6. And to finish out the side lengths, here's our adjacent side. We need to figure it out. So 1 squared plus a squared. Hey, look at that. It doesn't look like a 0. Equals 6 squared. So a is the square root of 35. If you do the math, I think we can all figure that out. It's just simply taking 6 squared minus 1 squared and then taking the square root. So a is equal to the square root of 35. Now we have all 3 side lengths. We're going to blow through these. Cosine, tangent. Cosine is adjacent, so that's square root 35 over 6. Tangent is opposite over adjacent, 1 over the square root of 35. Double checking, 1 6. Okay. Secant. Secant does not go with sine over here. It's almost deceiving that they are across from each other in my answers, but that has nothing to do with it. That just is the order they printed them on the paper. So secant is that inverse of cosine. So we take the opposite or the inverse of cosine over 35. Cotangent and tangent, those are inverses. And there you have it. Look at that, under 7 minutes. So next up, we will go through these ones. I'll see how many of these I can get through in a video, but yeah, video 2, we've solved just like problems 1 and 2, except we had to make our triangles this time. So I'll see you in the next video.